All right, guys, welcome back to my videos about inequalities. Today we're going to be talking about systems of inequalities, and in particular, we're going to be talking about how you can solve systems of linear inequalities by graphing. Okay, so we're going to have to do a little bit of review of how to graph lines and stuff like that, but overall, I think that this is going to be pretty straightforward. Again, as always, if you do not understand, make sure that you contact me, flag me down, and ask questions. All right, so let's jump right into it. All right, so just to review graphing a line, remember that we always put it in y equals mx plus b form, where y is the y variable, m is going to be our slope. Okay, so m here is going to be slope. Okay, so that's our rise over our run, how much we go up over how much we go over. X is just the x variable plus b, which is going to be our y-intercept. That's where on the y-axis we're going to hit. All right, so we use the slope. Okay, so the first thing we do is plot the y-intercept, and then we use the slope to plot at least 2 more points, and then we draw the line. All right, so let's look at some examples. All right, so here we go. These are already in y equals mx plus b form. So what I'm going to do is I'm just going to zoom in a little bit over here. All right, so if we look at this one, okay, the very first thing I notice is that plus 5 is our y-intercept. So I'm going to go up 5. So 1, 2, 3, 4, 5. That's going to be right about there. Okay, now my slope is 3. And remember that this is rise over run, so I can think of it as 3 over 1. So I need to go up 3 and to the right 1. Okay, so 1, 2, 3. And the next point would be right there. All right, so notice that if I go up 3 again, I'm at some point way up there off the graph. So what I can do is I can actually switch my 2 ways and actually go left 3 and down 1. Because if you imagine, okay, if both of these are negative, so left is negative, down is negative, and negative divided by a negative is a positive 3. So if I go right there, that would be my next one. And then I'm just going to draw my line. And hopefully yours is just a little bit straighter than mine through my points, and that'll be my line. All right, so let's move on to the next one. Okay, let me go over here. Now, notice that this one is not in y equals mx plus b form. So what I'm going to have to do is get it into that form. So the first thing I'm going to do is get y by itself. So here we go. We got 3y. We're going to subtract 2x to the other side, subtract 2x. And I'm going to get 3y equals negative 2x plus 6. All right, last step, I'm going to divide everything by 3. Okay, I'm going to go over here now, and I'm going to get y equals negative 2/3 x plus 2. All right, so now we're in the form I need. The first thing that I notice is that my y-intercept is 2 over here, so let's go plot 2 on my y-axis. That's going to be right there. Okay. And then I need to do a slope of negative 2/3. So if you imagine negative 2/3, that means I go down 2 and right 3. Okay, so I go 1, 2, 1, 2, 3. There's 1 point. 1, 2, 1, 2, 3. There's my other point. And again, I'm just going to be connecting these dots. And hopefully you can draw a lot straighter line than I can on this iPad. All right, so as always, if this didn't make sense, okay, this was an Algebra 1 concept, so depending on how much you remember from Algebra 1, this may or may not have been easy or difficult, but make sure if you don't understand that you stop me and call me over so that I can show you how to do this. All right, so next we got the steps for graphing inequalities. Remember that inequalities are those ones that have the less than or greater than or equal to, less than or equal to in their expressions. Okay, so to write the inequality as an equation, okay, you need to first get it into slope-intercept form. So in our case, that's going to be y is less than mx plus b, or y is greater than mx plus b, that sort of thing. Okay, now, the thing is that we need to make sure that if it is less than or greater than, it gets a dashed line. So if you remember back to when we were doing a number line, okay, one's like less than or greater than, okay, like these two, they always got an open circle. So they got this, and then we would shade to the left or shade to the right, either way. Okay, and our less than or equal to and greater than or equal to, so these two are going to get a solid line. Okay, so we're going to make sure that those are a solid line. Dashed lines are going to look like this. Okay, solid lines are going to look like this. They're going to be all connected. Okay, so what you're going to do next is you're going to test a point not on the line to see if it makes a true statement. So for example, okay, if you get something that says 2 is less than 3, that's good. Okay, that is a true statement. Okay, but if you get something that says 5 is less than 3, then we're going to say, no, that's not a true statement. Okay, if true, you're going to shade towards that side. Okay, so you're going to shade towards the point that you'd plugged in. If false, you're going to shade away from the point you just tested. Okay, so let's see how this is actually going to work when we actually do this. All right, as always, make sure that you are writing these things down in your notebooks so that you can refer to them later. Okay, but let's... All right, so we're going to start out by graphing y is greater than x minus 4. All right, so we graph it just like a normal line, so we notice that our y-intercept is at -4. Okay, and so what we're going to do is then graph... Now, this is kind of tricky. Remember that our y-intercept, or our slope here, is 1, so that is 1 over 1. So we're going to go up 1 and right 1. Okay, so here, and here, and here, and so on. So this up 1, right 1 line is like this. Now, I've made a very, very key mistake in graphing this line, because if you'll notice that this is y is greater than x minus 4. Okay, remember greater than is a dashed line. Okay, so let me go and let me erase this. Okay, so if you have to go back and erase it on your paper, make sure that you do so. And I'm going to go to -4, and I go up 1 over 1 this entire way, and it's actually going to be a dashed line. Okay, so this is kind of hard to make with a stylus on this iPad, but you can imagine I have this dotted line that goes like that. Okay, cool. So now we need to determine where to shade. One of the easiest points that I've kind of alluded to up here, okay, always if you can, so if your line is not going through the origin, test the origin. Okay, so we're going to test 0, 0 right here. Okay, so let's sub in 0, 0. So I sub in 0 for y, sub in 0 for x. Okay, I get 0 is greater than -4. And I determined that that is true. Yes, 0 is in fact greater than -4. So I'm going to shade towards that point. Okay, so notice that I shaded my red towards that point. So everything on this side of the line is a solution to this inequality. Okay, again, if the shading doesn't make sense or the graphing the line doesn't make sense, make sure that you call me over so that I can clarify. All right, next one. Okay, notice again that we're not in y-intercept form, kind of like some of the examples we did with graphing. So what we're going to do is we're again going to get y by itself here. So I'm going to look at 2y is greater than or equal to -4x plus 8. Okay, so I'm subtracting 4x to the other side on my equation. Okay, finally I'm going to divide everything by 2 to get y by itself. So y is greater than or equal to -2x plus 4. All right, so now I'm in graphing form, so I can certainly graph this thing. Got to go up 4. 1, 2, 3, 4 is right there. Okay, and then I have a slope of -2, so you can imagine that's -2 over 1. So I need to go down 2 and right 1. Okay, so I go down 2, right 1, down 2, right 1. Now this one, as you can see, is going to be a solid line because I have that or equal to sign right here in between my two things. So this one is going to, in fact, be a solid line that goes kind of up and down like that. Okay, so now again, we have to determine where to shade. Okay, so again, the easiest point to pick is the origin. Okay, so if I sub in 0, for x and y, okay, and I'm doing that back to the original equation. I get 4 times 0 is 0, okay, 2 times 0 is 0, and then 0 plus 0 is just going to give me 0. And this thing's going to say 0 is greater than or equal to 8. That is not true. That is incredibly false. So we put a big red X and say, nope, that does not work. So what I'm going to do is I'm going to shade away from that region. Okay, so see how 0, 0 was on the left here. Okay, it's right there. Okay, so I'm going to shade away from it because I know that that point doesn't work. Okay, and so that's what it looks like if you shade away from a point. Now again, if this doesn't make sense, make sure that you stop me and call me over. All right, so for these two examples, what I want you to do is pause the video, and I want you to try these out on your own. Okay, do not go forward without trying these. Okay, so pause the video, try them on your own. Ready, go. Okay, so let's take a look at these now that you've tried them out. Okay, again, this one, you do have to get into y-intercept form. So what you're going to do is you're going to subtract 4x, you're going to get negative 2y is greater than or equal to negative 4x plus 8. Now, here's the tricky part. When you divide by negative 2, remember that when you divide by a negative, you have to switch the direction of your inequality. So I'm going to get y is less than or equal to 2x minus 4. Okay, negative 4 divided by negative 2 is a positive 2. All right, so let's look at this. We're going to go down 4. So 1, 2, 3, 4. That's right there. And then we have to do a slope of 2. So that's 2 over 1. So we need to go up 2 and then right 1. So up 2, right 1, up 2, right 1. We're going to look like that. Now, this is less than or equal to, so that's a solid line, so it's going to look something like that. All right, so we need to pick a point again, so we're going to pick 0, 0 because that's not on my line. And we're going to go back in, and we're going to sub in 0 here and sub in 0 there, so it's going to look like this. 4 times 0. Actually, let me do it in a place where I can actually see. So 4 times 0 minus 2 times 0 is greater than or equal to 8. Okay, so 0 minus 0, that's just going to be 0. 0 is greater than or equal to 8. Is that true? Of course it's not. All right, so I'm going to graph away from my point. Okay, so it's going to be all over here. All right, so moving on to the next one. Okay, let me scroll over here. Okay, we have y is greater than negative 3x over 4. All right, so the very first thing, this is already in y-intercept form. This one's going to start at 0. Okay, let me get back to my black pen. Okay, it started 0 because I have no y-intercept out here, so I assume that it's plus 0. All right, so then on negative 3/4 slope, I go down 3 and to the right 4. Okay, so 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And then I draw my line. Let's see, make sure that it is dotted in this case. So it's going to look something like this. Something like that. Okay, excuse my marks, you know, I'm trying to do this on an iPad. Okay, so let's look. Notice that I cannot test 0, 0. Okay, that's a point on my line. I need to try something that's not on my line. Okay, so an easy thing to pick, 1, 1. Okay, 1, 1 is not on my line. So if I look and I sub in a 1 for y there and I sub in a 1 for x there, I get 1 is greater than negative 3/4 times 1. Well, 1 is greater than negative 3/4. That is definitely true, so I'm going to shade towards that point, which is going to be all this way. Okay, and it's going to look like that. All right, now, I do want to talk about these examples very quickly as to not waste too much time, but they do come up every so often. So if you imagine y is greater than 1, well, the line y equals 1, this is a horizontal line at 1. Okay, so right here at 1, okay, we're going to have this horizontal line, and whoops, I forgot again that this needs to be dotted, okay, because it's not equal to. kind of like that. Okay, and everything greater than 1 is going to be everything that is above this line, because if you imagine like 2 is greater than 1, right? Okay, so you're going to graph it like that. Likewise, if we look at the next example, okay, we have x is less than or equal to negative 2. Okay, x equaling negative 2 is in fact a vertical line at negative 2. It looks like this, okay, exactly where x is negative 2. And it's solid because it's or equal to, and everything less than is going to be in fact to the left of this line, so we're going to shade it all over here. Okay, so that's a little bit of a difficult thing to remember. Everything that has only y, okay, y equals is going to be horizontal, and x equals is going to be vertical. Okay, so that's something to remember for future lessons. All right, so in particular, in this video, we're trying to graph systems. Okay, so a system is more than one inequality that we have to graph. Okay, so what you're going to do is you're going to graph each inequality and indicate the part that should be shaded. Okay, the area that is the overall answer is the one that they share, the common graph area that's being shaded. Okay, so it's going to overlap. Okay, so you can pick any point in the commonly shaded area and check it in the inequalities. So here we go. Okay, so this one's already kind of done for us, but let me just explain what's happening here. So we have x plus y is greater than or equal to 3. So they're actually going to graph the line y is greater than or equal to negative x plus 3. Okay, so you'll notice that they came up here to positive 3, and then they had a negative 1 slope that went down like that. All right, for this one, they're going to go y, so technically negative y, is greater than negative x plus 1. And then what happens is that you divide by a negative 1 by everything, negative 1, and you get y in the inequality right here switches ways, so it's going to actually be pointing this way now. And then we get x minus 1. Okay, so they go down to negative 1. It's a dotted line, and I'm going up 1 over 1. Okay, and that's how they get that. So what we're going to do is we're going to choose 0, 0 to test. Okay, so if you imagine the very first one, they get 0 plus 0 is greater than or equal to 3. Is that true? Okay, is that true? No, it is in fact false. Okay, and so that's why they shade in green away from 0, 0. Okay, so that's over here. Okay, for the next one, they do 0 minus 0 is greater than 1. Is 0 going to be greater than 1? No, that's going to be false. So you're going to shade away from that one as well. So it's going to be this way. Now, this area, and let me do it in blue, this area right here, where they overlap, is the answer that we're looking for. Okay, so all the points contained in this little area are solutions to my system. In other words, if I picked this point right here, which is at 4, 1, that satisfies both of my equations. Okay, so for example, you can test it out. 4 plus 1 is greater than or equal to 3. Okay, well that's 5 is greater than 3. That's true. Okay, 4 minus 1 is greater than 1. Well, 4 minus 1 is 3. 3 is greater than 1. Yes, it checks off for both. Okay, so this entire area, again, is our answer area. All right, so let's try one out. Okay, so the very first thing we're going to do is we're going to get y by itself. So we're going to get negative 3y is less than negative x plus 6. Okay, we're going to divide by negative 3, divide by negative 3. Okay, we get y. Remember that we'll have to switch the sign because I divided by a negative. 1/3 x minus 2. All right, so let's graph that. That's going to be down here at negative 2. And now 1/3 is going to be up 1, right 3, there and there. And now I just need to make sure that this is a dotted line. Just pretend that it's a dotted line and it looks good. Okay. All right, so then let's do the next one. I'm going to get 3y is greater than or equal to negative 2x minus 6. Divide by 3, divide by 3, divide by 3. Y is greater than, now this one I don't have to switch because I'm not dividing by a negative, I'm dividing by a positive, equals negative 2/3 x minus 2. All right, so again, this one is going to intersect right here. Let me do this in a different color. I'm going to do it in blue. Okay, so at negative 2 right there, and I'm going to go down 2 over 3, down 2 over 3, and this one is in fact going to be a solid line like this. Okay, so again, we're going to choose 0, 0 to sub into both of them to see if they work. All right, so I'm going to get 0 minus 3 times 0, that's a 3, just pretend, is less than 6. Okay, so is 0 less than 6? Yes, in fact it is. Okay, so for the black line, okay, I'm going to shade towards 0, 0. Okay, and so I typically only just make a little bit of the lines because I don't know exactly where my area is going to be yet. All right, so for blue, I'm going to get 2 times 0 plus 3 times 0 is greater than or equal to negative 6. Okay, so is 0 greater than or equal to negative 6? Yes, in fact it is. All right, so again, I'm going to shade on the blue line towards 0, 0. Now, where on my graph are my areas that are shaded overlapping? Well, that would be in this part right here. So notice that the black and the blue are overlapping in this area. Okay, so ultimately this is the area that I'm looking for. All right, so let's look at one more example and then you'll be free to work on your assignments. Oh my gosh, now what are we going to do? There's 3 inequalities involved in this one. We're going to have to figure this out. I don't know how to do it. All right, so let's look. Let's start out with the very first one. Okay, so we're going to get y is less than negative x plus 2. All right, so we're going to start up here at positive 2. Okay, and we're going to go, since this is negative 1, okay, we're going to go down 1 over 1. It's going to look something like that. Okay, it's all going to be dotted. Okay, so I need to redo that. That looks way too bad. Okay, so that's better. Something like that. All right, so notice this next one says that negative 2 is less than or equal to x. Or in other words, x is greater than or equal to negative 2. Well, like we talked about in previous ones, the way to graph that is a vertical line at negative 2 right there. And then if you imagine there's another part here that says x is less than 1. Okay, so that's going to be graphed at 1. Let me undo that. And it's going to be right there. Okay, so then imagine shading for this one is going to be all in between negative 2 and 1. Okay, so that's where my shading is going to be for the red line. I'm going to do the y-axis one in blue. So we're going to graph here a horizontal line at negative 3, and it's going to be dotted. Now, it would actually help if I make it dotted. Okay, like that. And this is everything greater than negative 3, so it's going to be everything up here. Okay, so notice that I only actually have to test a point for x plus y is less than 2. So again, I'm going to test out 0, 0. That's right there. Okay, so if I sub in 0, 0 plus 0 is less than 2. Is 0 less than 2? Yes, that is true. So for the black line, I'm going to shade towards the black line. Now think about, I need all 3 of these areas to intertwine, and that's going to cause me to shade right in here. Okay, so this is where all of the shading intersects. Okay, so 3 doesn't really add anything different other than it's just more stuff for us to graph. Okay, and we just map where everything intersects. Okay, so like always, If none of this made sense, or if some of it made sense but you're still a little iffy on some things, make sure that you call me over so that I can explain it further. Thanks for watching.